How's it going, AP Stats students? Shane here from Fiveable. I'm excited to continue on your journey for statistics. Right now, it is the end of October, which means we are just chugging right along. You've had a couple tests. You're starting to get an idea of the power of statistics, and where it can go is only up. So, as always, I'll be going live every Thursday. Let me share with you my screen so we can see. I'll be going live at 5 p.m. Pacific Standard Time or 8 p.m. Eastern Standard Time. I'm seeing a lot of you come in now. Excellent, excellent. How's it going, Dylan? Hopefully you guys are around chapter 3 of your textbook. I know my students were towards the end of chapter 3, which is the least squares regression line. If you are, just go ahead and comment in the chat so I know. And again, use that chat to ask me questions. The greatest part about Fiveable is we get to interact no matter where we are, and you can stop me and ask questions. Some of the best discussions and learnings come from students asking questions. So please, please, please ask questions. I will stop and dive into them. So this is going to be part 1 because linear regression is a little bit meatier. I'm going to spend 2 sessions covering it, so this one and next one. However, if you have a question about something that I didn't cover and you know you're going to be tested on it tomorrow, ask, right? That's what I'm here for. My students won't be tested on this until next week, so I am going to spend a little bit of time on it. Here's what we're going to cover. Right now, we're going to cover the least squared regression, a little bit of residuals, but next time we're going to cover R squared value as well as the regression output. So regression output is what you will get on the AP exam, which will kind of do the line of best fit for you. But for now, we're going to save that for next week. As always, you're going to get some exam tips from me, some FRQs. We have one FRQ today, some multiple choice questions, calculator tips. If you don't have your calculator by you, go ahead and grab this because this is going to save you a lot of time and headache. So go ahead and grab that now. All right, let's dive into it. All right, so least squared regression. So if you were with me last week, you saw us cover some things and we're going to go over that. But for today, we're going to cover the regression line and how to interpret it. So interpreting is really, really big in statistics, particularly in this unit. So I'm just going to give you a couple sentence frames, and all you have to do is whatever problem comes up, just plug in a couple things. So we're literally going to write everything for you. All you have to do is whatever problem, just plug in the context. And again, we'll work on this as we go on. Extrapolation. So we're going to talk a little bit about extrapolation. Next, residuals. So what is a residual? How do we find one? And the least squared regression line, which we'll also kind of talk about in the beginning. So let's dive into the first part, which is the regression line. Let's go. Why isn't this working? Hold on one second. Let's see. All right, we're gonna have to quickly open this back up. I'm not sure why it stopped. Give me 1 second. Sorry about that. That's never happened before. Pull up my PowerPoint. Maybe it's my internet. Can you guys still hear me and see me? Hello? If you can hear me or see me, can you comment in the box below? Okay, it looks like my internet's back. Working? There we go. Okay. Sorry about that. I lost a couple of you. Come on back. The internet is working. Promise. Come on. So close. Okay, there we go. Awesome. So regression line. So it's a line that describes how a response variable changes as an explanatory variable changes, and we use it to make predictions. So this is really, really powerful to make predictions based off of data that you collected. So we use data that we collect. We create a line so that we can then make predictions about data points that we don't have. So for example, yesterday, I took my students' height and their hand span, and we plotted it on a regression line. So this is actual data that I gathered from my students, and we plotted it. So a regression line would look something like this, where we actually plot the line based off of the data that we see here. So you can see up here our correlation is 0.646, which we'll then go back and review what that means. And then here's actually the equation for our least squared regression line, which we'll come and take a look at too in a minute. So let's review. Whoops. Review. Had review slides. Where was it? Okay, here we go. We're going to quickly review. This is my explanatory variable, the x. My response variable is always your y. Remember, your explanatory explains what would happen in your y. And when we describe correlation, this is from the last video, but I do want to give you guys a minute to check it out and make sure we're up to date. So first we want to talk about direction. Now these are all the things you're going to have to hit on your AP exam to make sure that you score a 5. So this direction here is positive. Talk about anything unusual. And there's probably one potential unusual point or outlier, this person down here. And again, this is something that doesn't follow the trend. The form. So this is a linear form. And for this class, we're going to focus on linear and nonlinear. Anything else we don't need to worry about. The strength and context. So the strength is moderately strong. And you always need to include context when you're talking about your AP problems. So that's just a review of how to talk about correlation. We're going to take it one step further and talk about regression line. So once again, regression line describes how a response variable changes as an explanatory variable changes. So as x change, how does my y change? And we use it to make predictions. So like I said before, here's some data I gathered from my students yesterday. I took their height and their hand span, both in centimeters, and we graphed it. So when we graphed it, we saw a positive, linear, moderately strong relationship between the two. And when we actually calculated the line of best fit, here's what we got. We got our correlation value as 0.64, and we got our equation listed below. Now we're going to learn how to actually calculate that in a minute. But for now, we want to learn how to interpret it, because that's going to be a big part of your statistics exam. So once again, we took the data that we gathered from my students. Using that data, we made a line of best fit. And this only works for bivariate data. So you're never going to use this for univariate data. Bivariate data, again, means that you're getting 2 data points, or 2 quantitative variables for every 1 data point, I should say. So in this case, each one of these dots represents a person, and each of these people have 2 quantitative variables. One is their height, again, quantitative being a number, and the y is their hand span, again, a number that we can measure. So as we take a deeper dive into the actual equation, we're going to see a lot of different parts to it. The first thing you're going to notice is this looks a little bit different than my Algebra 1 class or your Algebra 2 class. And it should look kind of familiar, but also a little different. And normally you're probably used to a linear equation being y equals mx plus b. This is a little different. We just switched the mx and the b. We switched places, and we call it a plus bx. And so in this case, our A is the y-intercept right there. And so it's the predicted value when x is 0. We really want to focus on the importance of having x equals 0, and it is a prediction. Because the line that we created is a predicted line, we can't say for sure that if a person has, in this case, this is a height of 0, that their handspan would be negative 1.68. Once again, this is a predicted. So you want to use the word predicted whenever you're interpreting the y-intercept. Other thing you're going to notice is this is not just y, it's y hat. So we call it y hat. It's got a little caret on top of it. And it's the predicted value of our y variable given an x variable. So for example, if I wanted to predict how big someone's hand size would be, if their height was like 160 centimeters, I would plug in 160 there, and what would come out would be my y hat, or my predicted hand size for someone with that height. So it's important, again, that we talk about the predicted. And last but not least is our slope. So our slope, and as you can see, I've been doing that with my Algebra 1 kids as well. Our slope is also a predicted measurement. This whole line is a bunch of predictions. So the slope is the amount by which y is predicted to increase or decrease. So I just use the word change when x increases by 1 unit. So as I move my x by 1 unit, what happens to my y? Well, our slope tells us that. And we'll get into some problems because, again, the best way to learn stats is to actually do it. So, talked about our line of best fit, our linear regression line. Now let's go to extrapolation. Extrapolation is when we use a regression line for predictions way outside the values that we obtained to make the line. And the predictions are often not accurate. So for this example, I took data from students' age and their height. So as we can see, there is a positive, strong, linear relationship between age and height. And we see that right there. And our R value proves it. It's 0.996. So then we took the equation that I created, and I'll show you a website that helps you out with that, as well as our calculator. We'll do all that with the calculator. So the equation was down here. Now extrapolation would be using this equation to predict how tall someone would be if they were 100 years old. Now, obviously, we're going to have some issue with that. But let's predict how tall someone would be if they're 100 years old. So let's go to this. First, let's write down the equation. So the equation is y hat equals 79.13 plus 5.92x. All right, so now we're going to predict, and just to show you extrapolation and the dangers of it. So remember, y hat is the predicted height. And that is your age. So if I wanted to predict how tall someone was going to be at the age of, let's say 100. So I would take y hat equals 79.13 plus 5.92 and multiply it by 100. So I'd get y hat equals 79.13 plus 592. And if you add that up, 592 plus 79.13, you're going to get 671.13. So according to our line, we would predict that someone who's 100 years old is going to be a height of 671. Now that's obviously absurd, and that's because of extrapolation. Once again, we can't use data that is far outside our range. So if we're looking at our data that we have here, we really wouldn't want to extrapolate any further than maybe 22, 23, because that's going to give us some, it's just our data is not clustered there, so we don't know what happens as you age, right? We can only really make predictions within a certain range of our data. And something too outrageous like that's 80 years, that's 80 in our explanatory variable, that's 80 data points away or 80 units away. And that's just not going to work for us. We're going to get something absurd, just like we did. And usually something else tells you why it's absurd. So in this case, we know humans stop growing for the most part after about 20, 22, 23. You're for sure done growing. So that's a little bit of extrapolation. Just like we couldn't predict someone who, let's say, was negative years old. Obviously, you can't be negative years old, but it's outside our data set. That's a little bit more about extrapolation. I'm going to go back to the equation. So each of these parts of the equations, you're probably going to have to interpret at some point on the AP exam. And like I said before, I'll give you guys sentence frames so you guys can just use that sentence frame on every single one of these questions to get full credit on the AP exam. So first we're going to start with slope. Go ahead and screenshot this, write it down. This is how you're going to interpret slope on the AP exam. And what we say is for every blank, either increase or decrease of 1, and then whatever the unit is, insert your context for X, we would predict, insert your Y, to increase by or of this amount, and then slope and units. So this you can just use on any part of your AP exam when they're asking you to interpret, as well as your teacher's tests. So here's an example with our data from my students yesterday. So here's the equation. There's our slope, 0.1175. And so the way we would interpret that is for every increase of 1, what's our explanatory variable? So it was centimeter of height. There is we would predict a increase of 0.1175 centimeters in their hand span. So let me say that again. We would, or for every increase of 1 centimeter in height, we would predict that hand span would increase by 0.1175. And again, just use that sentence frame every time and you'll be good to go because you're getting context and you're breaking down what slope means. So you'll have to interpret slope. You'll also have to interpret the Y-intercept. Y-intercepts may be a little bit easier, hopefully a little bit more intuitive for you. And here's how we do Y-intercepts. When insert context of X is equal to 0, we would predict that the insert context of Y would be, and then put your Y-intercept. So I think the Y-intercept is a little bit easier. And let me show you how it's done with the example from my students' data yesterday. So here's the equation again. And here's how we would interpret the Y-intercept. Excuse me. Whew. When the, insert our x, and our x was height. So when the height in centimeters is 0, we would predict that the hand span would be negative 1.68. Now, obviously, that can't be true. You can't have someone with a height of 0 and a hand span that is negative. However, that is how we interpret it, and that is what our line of best fit is telling us. So it might not make sense, and you can mention that in your response if they ask you to interpret the y-intercept, but we do still want to interpret it nonetheless, because they will ask you, what does the y-intercept mean? Or what does, in this case, they would say, what does negative 1.68 mean? So if there's any questions, shoot them my way. Covered a lot so far. And once we do the free response question, it'll kind of help us break it down a little bit more. The last thing I want to touch on is residual. So residual is basically the observed minus the predicted. And the way I always remember this, because I sometimes forget, is it predicted first or observed? But after this, I never forgot it. Since O comes before P in the alphabet, it's always observed minus predicted. And whoops. So you can think of it in terms of your age or height versus handspan. So what I had my students do is they investigated a crime that happened in my classroom. Someone took all my LaCroix, but I found a handprint on my fridge. So we used data from the class. We measured their height and their handspan. So we measured their height and their handspan. And we said, okay, what would we predict the height of the person to be given the hand size on my fridge was this. So in this case, it was 16. And so we got a predicted number. To get your residual, you would take your predicted height or your predicted handspan and subtract it from the actual handspan. Let's try an example together. So let's look at our example. And if you have your calculator available, go ahead and take that out. That's going to come in handy. This is an AP problem. It is from 2015, I believe. No, 2005. Sorry, 2005. And it has the Great Plains Railroad is interested in studying how fuel consumption is related to the number of rail cars for its trains on a certain route between Oklahoma City and Omaha. So we're looking to see how much fuel consumption is used based on the number of rail cars we have in our train. So a bunch of data, and we want to make some predictions. So the first thing we're going to do is enter in our data into our calculator. So go ahead and turn it on. As always, to enter in data, you're going to go to Stat right there, Edit. Anything that's in your calculator, you can just go to the top, hit Clear, Enter. Go to the top, hit Clear, Enter. Don't hit Delete. That's going to delete your lists, and you don't want to do that. So then we'll enter in our explanatory variable. Remember, explanatory. And we know this is explanatory because, let me write this out. The number of rail cars might explain how much fuel you use. So that's the explanatory. This right here is going to be the response. So we have the explanatory variable and the response variable. Let's go ahead and type those in. We got 20, 20, 37, 31, 47, 43, 59. And there's that. We got 58. This is one of those times that you want to be careful and make sure that they line up, because if they don't line up, it's going to mess up your data. And when I say line up, I mean make sure 47 and 114 go together. 47 and 114. Okay. All right, so how do we actually graph it? We're going to second stat plot. And we're going to go into stat plot 1. We're going to make sure it's on. Make sure it's your scatter plot, which is the first graph. L1 and L2 is where I entered in my data. If you did something different, that's fine. You can enter it in there. And then you're going to hit the zoom button and stat. And we're going to see something like that. So if we were to describe this, if we wanted to describe the distribution, we would say there is a positive linear strong relationship between, and then here's where context comes in, between number of rail cars and fuel consumption. Units per mile. So we touched on direction. It's positive. On strength, it's strong. Unusual, there's really nothing unusual. Context. And we touched on form. So all the parts needed to make sure that we have full credit on how we would describe it. Now, if we wanted to get the line of best fit, super, super easy. You go to stat, go to calculate, go down to number 8. Now, you're probably asking, Shane, what's the difference between 4 and 8? 8, there really is no difference. 8 is just what we use in stats, and the AP tests use it, so I'm going to push you to use 8 and not 4. So you're going to hit enter, and then you want to tell the calculator, where is my data? So you're going to hit second, then the 1 button, comma, second, the 2 button. Now, if you put your data in L1 and L2, you actually don't need to do that. If you just leave that, it'll assume you're talking about L1, L2, and just generate stats from L1 and L2. But if you use something other than L1 and L2, you're going to have to type it in. I always type it in anyways, just because. So I always tell my students to do that as well. So here we go. We got our line of best fit. Let's go ahead and write that down. Remember, it always starts with your Y hat. Y hat is your predicted, because this line is a predicted line. Y hat equals our A, which is 10.6, and I'm going to round it to 8, plus our slope, which is 2.1, and I'm going to round it to 5, times X. So there we have our line of best fit. We also have our R value. R equals 0.98, which helps us confirm that there's a strong relationship, that it's positive, and that it's linear. We'll talk about R squared on the next part. But for right now, let's just worry about our interpretations. So we really want to start to interpret what each of these are. So let's look at our Y-intercept. Now remember, to interpret our Y-intercept, we want to say when and then context of X. So when the number of rail cars is 0, we would, and this is where you need to use the word predict. If you don't use the word predict, they're gonna mark you down. Use the word predict. So we would predict and again, go back to those sentence starters. If you're just joining us, Jason, I gave us a list of sentence starters that all you have to do is input your specific context and it'll work every time to get you full credit. So we would predict that and then insert your context for Y. So our Y here, our response variable, is the fuel consumption. Would be, and then insert your number, 10.68 units a mile. And that gets you full credit for interpreting the Y-intercept. You're also probably going to have to interpret your slope, which is right here. And I'm going to interpret it down here. Again, go back to those sentence structures that I showed you, and it'll... Awesome. How do you think you did? Good. Yeah, it's a quicker unit, but it's pretty dense. And in the past couple of years, they've had a question like this on the AP exam. This is from 2005, but there was one in 2017, 18, I think 16 as well. So it's likely going to be a free response question. Awesome. I will do that. Perfect. I love this. Let me finish interpreting slope, and then I'll get to the R squared. And I'll give you a sentence starter for it, Jason, so you can just use that every time. So we would say for every, and in this case, it's going to be increase of 1, and then put the unit, so 1 rail car, we would predict an increase, because it's positive, an increase of 2.15 units mile. And that's it. We got context. We interpreted it right. That's perfect. Okay, so we asked about R squared, which is our coefficient of determination. So if we look over here, and I'm going to scoot this down so I have more space to write. I'll cover this next week, but I will talk about it now since you're here. So our R squared for this one was 0.967. Do you know how to do all this on your calculator, Jason? Yep, exactly. And we use the A plus BX in statistics just because. So here's how you do it. First, I'll just give you the sentence starter, Jason, and then I'll actually plug it in with this specific context. So you would always start with the actual R squared number, and you would say that percent of the variability in, and then here you're going to insert your Y. So I'm going to do a different color just so you know this is where you insert something specific to whatever the context is. So you're going to do context of Y. Can be explained by the linear association with, and here's where you insert your context for X. And this also should be specific to your problem. So for this problem, we would say 96.7% of the variability in fuel consumption can be explained by the linear association with rail cars. And so what this is really saying is, hey, when I change, or the change in fuel consumption, 96.7% of the time can be explained by the number of rail cars. The other 3.3% of the time is explained by something else. And maybe that's wind, maybe that's what's in the rail cars, maybe that's how hilly it is, anything like that. I guess not how hilly, because this is all one track, but it's something else that's explaining why we're getting a different fuel consumption than what we would see. Okay, cool. Very good. Very good. Yeah, just write that down. Keep that in your notes, and you're going to be good to go. Anytime you get to that, I mean, I would maybe make a flashcard and just kind of, get that ingrained in you. But I think also understanding why we explain it that way is important too, because that'll help you remember. So once again, it's whatever percent in variability of y can be explained by the change in x. Essentially, variability and change you can use for this. If you use that, you'll get 100%, a 5 on the AP exam, or a 4, I guess, on that question on the AP exam. Did you talk about residuals, Jason? Yeah, okay. So we're going to dive into residuals as well. We talked about what a residual is, but here's how I remember it, because sometimes you don't know, is it predicted minus observed minus predicted? So residual is always going to be your observed minus your predicted. Yeah, yep. And here's how I remember it. If you do the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So O comes before P, so it's observed minus predicted. I find my students like that. It helps me remember it. So hopefully that's something you can stick in your back pocket and take it with you. So observed minus predicted. O comes before P in the alphabet. There we go. So we can take a look at our residual for this problem. And I'm going to cover this up so I can continue to write. So the way we get predicted values, and again, I'm sure you did this on your quiz today, but let's double check. The way we get observed is we just plug in our number to our x value. So if I wanted to know, hey, what would I predict the fuel consumption to be if I had 20 rail cars? I would change x to 20. See what comes out. So if I take my calculator and I do 2.15 times 20 plus 10.68, I'm going to get 53.68 units a mile. So once again, we are predicting. We're not saying for sure, but we're predicting, according to our linear regression line, that if you have 20 cars, you're going to use this much fuel consumption. But we actually have a data point here that tells us how many we did. So we'll do observed minus predicted to get our residual. And our observed is 58. Our predicted is 53.68, which means we have an a residual of 4.32. Now, if you ever get a positive residual, you know that your observed was bigger than your predicted. And if you get a negative residual, that means that your observed was actually smaller than your predicted. And essentially what that allows you to kind of gauge is, was your line of best fit an overestimate or an underestimate? So in this case, our line of best fit was an underestimate, because what actually happened was 58, but what we estimated was 53.8. Does that help a little bit? Yeah. Once you get kind of the conceptual understanding of it, this stuff becomes a whole lot easier. I'm going to quickly go to the AP problem. I didn't print out the whole thing, but I'll go to the AP problem just so we can see what kind of questions they asked. And actually, let me show you what they asked. Close this. So here was the AP problem that I pulled from. And here they have oh no. Yeah, this is 2005. Back in the day. Does your teacher, Jason, give you actual AP problems as part of your test? Yep. Awesome. So yeah, I do the 25 multiple choice individually, and then I give my students actual AP problems. Where are you from, Jason? You from California at all? Yeah. Okay. So you guys do it in one sitting. Georgia. Nice. You guys probably do it in one sitting, and is it a block period or is it a skinny period? So is it like 50, 55 minutes or is it 130? Yeah. So yeah, that's a lot. If you think about FRQs, you should be spending about 15 minutes on an FRQ, which is about 30 minutes. And then you should be spending about no more than 2 minutes on your multiple choice, which means your teacher's doing something great. He's kind of structuring, or she's structuring it in a way that you'll actually have to use that time on the AP exam. Yep. So here's the question, or here's the prompt from 2005. And they plotted it for you. Yeah. Awesome. So this is right up your alley. Keep me informed about where you are. Like if you're taking your test for chapter 3, let me know and I can kind of gear, especially if it's just you and I in here, I can gear these lessons specifically towards you. So here's the residual plot. We'll talk more about residual plot next week because we're coming up on time. But look at the first couple questions, or look at C, interpret the R value. So if you use that sentence starter that we talked about, boom, you got that part. This one, we talked about this earlier using extrapolation. Did you guys talk about extrapolation in your class? Yep. All right. So this question's great because, again, it's asking about extrapolation. And, ooh, very good. So extrapolation here, we wouldn't need, or we couldn't really predict how much we would, or how many, it wouldn't be reasonable to use this line of best fit because the biggest data point we have is 50 and 65 is too far away from the data that we collected in order to say, hey, we could accurately describe what the fuel consumption would be for a route that had 67 or 65 cars. B is a great question. It's saying, hey, suppose fuel costs $25 a unit. Give a point estimate, a single value for the change in the average cost of. How would you explain actually, can you hit the ask question button just so other students know that I answered this question when they go back to watch it? So how would you, cool, thanks you. How would you explain the nearly normal residual for number, is that 1? So for the first question. So it's saying, is a linear model appropriate? So remember, we use R to talk about is something linear or not, is linear regression good, as well as using a residual. So if you look at our R value, which we'd have to square root this, but we know it's 0.98, that means that linear model is good because the closer it is to 1 or -1, a linear model is good. So you could use that as part of your answer, but you also want to look at your residual plot. If you notice your residual plot there's kind of no pattern and data falls equally above and below, that's good. That means that linear model is best. So if you look at your residual, we have some that fall above and some that fall below, meaning our line of best fit sometimes over predicts and under predicts, but it's not biased one way or another. So we're not constantly under predicting, we're not constantly over predicting. We're in a good spot. So our line might look somewhere around there. So based off of our residual plot, which is scattered and no pattern above and below the residual line, and our R value is so strong, we know a linear model is appropriate for this data. And then once again, your residual is the value from this line all the way up here. So it looks like when we had 50, what was that, maybe 52 cars? Or let's look at this one, 70. Oh, that's fuel consumption, I'm sorry. We were off by this much. And this one, we almost predicted it exactly, so the residual was very small. This is a great question. I wouldn't be surprised if my students see this question on their test. But this is what you're going to see most of the time when it comes to linear regression problems. They're going to give you the computer output. These two you want to know. For right now, you can ignore T and P. But eventually, we will look at P when we come to hypothesis testing for slope. So that's all I got for us today. Thank you, Jason, for sticking with us, and hopefully this was helpful. As we continue on in this journey, again, I'm going to be here every week. Oh, let me make sure I answered the question. Done answer. I'm going to be here every week, and I'm going to start providing more content as far as like study guides by chapter, and just kind of up my game to make sure that you guys are starting the process to really excel on the exam. Feel free to pop in and give me some, not pointers, but give me an idea of where you are. Like, Jason, if you're taking the chapter 3 test on Wednesday and I go live on Thursday, I could switch my days to Tuesday next week just to make sure you're getting the content before your test. So chapter 8, I think. What book are you using? So it's a green book, right? 3rd edition. Okay, I'll look into that. Yellow book. Okay, maybe I have the newer edition. Give me 1 second. Let me check real quick. This one? Stats Modeling the World. Oh, this is the 4th edition. That's probably why. So it's probably the same one. This is just the 4th edition. So it's a little bit newer. Oh yeah, this is a very interesting format. Have you done probability? Okay. All right. So you're roughly following the same stuff we're in. Oh, I see. Yeah, they just broke it up into smaller chapters. Yeah, so you're at 8, which is linear regression. We won't get too far into it, but yeah, you're following the exact same scope and sequence that we are. So we'll probably hit probability at the same time, sampling distributions, and all that stuff. So we'll be good to go. Yeah. I will see you. If you don't have your tests before Thursday, I'll see you Thursday. If you do have your test Thursday, let me know, and I can maybe move this to Tuesday. And then tell your friends. The more people we get in here asking questions, just the better discussions we're going to have. I'm letting my network go. I might start an Instagram page and just like post little small clips of just like different tips and tricks for the AP exam, or I might just go straight to Fiveable and use that account to do it. But okay, awesome. So we got time. And I'll bring in lots of free response questions and generate some multiple choice questions. Jason, you're doing the right stuff to make sure you're ahead of the game, not only in AP stats, but I imagine you're doing this in other aspects of your life. So keep doing that. It's going to take you far. And as always, I'll be here Thursdays, and have a good night. Adios.